Let's start with the reversible reaction. Normally, reaction they proceed in one direction. Reversible reaction, it's a type of a reaction in which reactants they consumed into products, and meanwhile products decompose back into reactant. So this type of reaction they are known as reversible reaction. So again, I repeat, reversible reaction, it's a type of a reaction in which reactants they consumed into products and products decompose back into reactants. So this type of reaction they are known as reversible reaction. And to show reversible reaction, we use this sign. This is half arrow forward and half arrow backward. This is a sign which is used to show reversible reaction. There are many examples of this reversible reaction. For example, hydrogen and iodine. They react with each other to form hydrogen iodide. This is a balanced chemical equation, and this shows hydrogen and oxygen they react with each other to form product, and meanwhile product hydrogen iodide decompose back into reactant. Another example for nitrogen and hydrogen. These two reactants they react with each other to form ammonia. Again, this is a reversible reaction. Two molecules of NO2 they react with each other to form N2O4. This is an example of reversible reaction. So again, I repeat, reversible reaction, it's a type of a reaction which proceed in both direction, forward as well as backward. Such type of reaction they are known as reversible reaction. Now, for example, this reaction, sulfur dioxide, SO2 gas, reacting with oxygen to form SO3. This is a reversible reaction. Before to start this reaction, amount of reactant that was 100 gram, and reaction haven't started yet. There is no product, then mass of product that is going to be 0 gram. Now, initial mass of reactant that was 100 gram and amount of product that is 0 gram. After a few times, this is 20 grams of product. Then amount of reactant there will be 80 gram because 20 grams of reactant they have reacted, and 80 gram of reactant will left. And if it is 30 gram, then it's going to be 70 gram. If 50 gram of reactant forms, then amount of reactant will be 50 gram. This stage is known as equilibrium stage. What is equilibrium? Equilibrium, it's a point when amount of reactant is equal to amount of product, that is known as equilibrium state. All the reversible reaction they try to maintain the position of equilibrium. Now suppose if 55 grams of product is formed, suppose, then amount of reactant there will be 45 grams, that will be a reactant. So it indicates equilibrium is disturbed. Now, to establish equilibrium, there must be 50 grams on the reactant side and 50 grams on the product side. But in this case, 55 gram they are on the product side and 45 gram they are on the reactant side. It indicates 5 gram of reactant they move forward direction. So this is equilibrium is disturbed. To maintain the position of equilibrium, again 5 gram of product that will decompose back into reactant, that will be again 50 grams and 50 gram. So again 5 grams that is coming back. At next stage, let's suppose if 60 gram of reactant is formed, it shows 10 gram of reactant they compose or they react to form product. To establish equilibrium, again 10 grams of product that will decompose to establish equilibrium. So it indicates if 5 gram of reactant that is moving forward direction, the same amount of product that will decompose. And if 10 grams they are moving forward, then same amount of product that will decompose. So this point is known as dynamic equilibrium. What is dynamic equilibrium? In dynamic equilibrium, rate of forward reaction is equal to the rate of backward reaction. Dynamic equilibrium is rate of forward reaction is equal to the rate of backward reaction. And keep in mind, reversible reaction they never complete. All the reversible reaction they never complete. So this was about position of equilibrium and what is meant by dynamic equilibrium and what is equilibrium state. Equilibrium state when amount of reactant is equal to the amount of product, that is equilibrium state, and dynamic equilibrium is when rate of forward reaction is equal to the rate of backward reaction, that is known as dynamic equilibrium. There are three factors which affect the position of equilibrium. Number one is temperature. Second is pressure. Pressure is only for gases. And third is for concentration. These are the three factors which affect the position of equilibrium. Number one is temperature. Increase in temperature. If temperature is increased, equilibrium will shift. Equilibrium will shift or shifts the equilibrium towards endothermic side. Towards endothermic side. And a mean of endothermic. What is mean by endothermic side? And what is mean by shifting of equilibrium? Shifting of equilibrium mean if equilibrium is, for example, this is a reaction between N2 and 3H2. It's forming a gas, ammonia, that is N2 and H2. It forms ammonia, product is 2NH3. And this is a balanced chemical equation. Forward reaction, this is minus 88 kilojoule per mole. This negative sign indicates forward reaction. This is exothermic. By using this negative sign indicates the reaction is exothermic. And this is the enthalpy change for forward reaction. If forward reaction that has a negative enthalpy change, then reverse reaction it's going to be positive 88. Amount of energy will remain same but sign will be different. So this positive sign indicates the reaction is reverse reaction is endothermic and forward reaction that is exothermic. This reaction normally it's occur at 400 to 450 degrees C. If you increase the temperature, let's suppose if you make temperature 500 degrees C, an amount of reactant, suppose that was in equilibrium state, that was 50 grams, and amount of this that is going to be 50 grams. Suppose this is an equilibrium state. By increasing this temperature, if you increase the temperature, equilibrium will shift towards endothermic side, and endothermic side is left side or reactant side. Left side is the reactant side and right side that is a product side. If you increase the temperature 500 degrees C from 4 or 450 degrees C, equilibrium will shift towards reactant side. So shifting of equilibrium mean amount of reactant that will be more, for, let's suppose 70 gram, and amount of product that will decrease. So this is the effect of temperature. So how you can explain for 2 marks, increase in temperature, equilibrium shifts towards left side or reactant side, 1 mark. 1 mark for direction and 1 mark for as it is endothermic. So this is a reason how by increasing temperature, if you increase the temperature from 450 degrees C, equilibrium will shift to the left side because it is exothermic. If you decrease the temperature, let's suppose you are going to decrease at suppose 300 degrees C. If you decrease the temperature for similar reaction, rate of reaction would decrease, but amount of product that will be more or equilibrium will shift towards product side. Now, second factor is pressure. How pressure can affect the position of equilibrium? And this pressure, it's only applicable for gases. This pressure cannot affect the position of equilibrium for liquids or even solids, but pressure is only applicable for gases. So increase in pressure, if pressure for an equilibrium mixture is increase in pressure shifts equilibrium towards less number of mole. For example, here you have a reaction. This is a reactant side. On the reactant side, there is 4 number of mole. Number of mole you will get from a balanced chemical equation. There is 3H2 and 1 nitrogen. There are 4 number of mole on the reactant side. This is 1 and 3. But on the product side, there is 2 mole. So on the product side, there is less number of mole. But on the reactant side, there is 3 and 1, 4 number of mole. So when you increase the pressure, normally this reaction occur at 200 to 250 atmospheric pressure, 200 to 250 atm. When you increase the pressure, suppose you are going to make it 400 atmospheric pressure. Due to increase in pressure, equilibrium, if pressure is increased, equilibrium shifts towards right side or product side. Why it will shift towards right side or product side? Because as it has less number of mole. But if pressure is decreased, suppose instead of 200, you are going to make it 100 atmospheric pressure. Now pressure is decreased. In this case, equilibrium will shift towards left side or reactant side. Why reactant side? As it has more number of mole. So due to increase in pressure, equilibrium will shift towards less number of mole, and decrease in pressure will shift towards more number of mole. So it indicates shifting of equilibrium mean reactant will be more. Amount of reactant that will be more and less product. And shifting of equilibrium towards product side, it shows product will be more and reactant that will be less. So this is the effect of pressure on the equilibrium. Now, third factor is concentration. How concentration can affect the position of equilibrium. Now, this thing you have already learned in the start when I give you introduction how equilibrium is established and what is dynamic equilibrium. When you change the concentration, either reactant or product, the change in concentration will shifts equilibrium towards less concentration. For example, here you have reactants that is 150 gram and amount of product that is also 150 gram. This is in dynamic equilibrium, rate of forward and rate of backward, they are same. Now, if I add 20 grams of nitrogen into it, normally there was 150 and 150, I added 20 gram of nitrogen. So concentration of reactant is now at this moment, this is 170 and amount of product that is 150 gram. Now equilibrium is disturbed because less number of grams of product that is formed and amount of reactant that is more. To establish equilibrium, 10 grams of reactant they will move towards product side, so it is going to be 160 and 160. So by change in concentration, what I did, just I changed the amount of reactant. When you change the amount of reactant, equilibrium will shift towards less concentration product that was less. So this is the reason amount of product that was increasing. Now let's suppose I'm going to remove some amount of ammonia. Suppose I'm taking off 30 grams of ammonia. Then 130 gram of product that will left and amount of reactant that is 160. So again, amount of product that is less. So equilibrium will shift towards product side. So this is effect of concentration, how concentration can change the position of equilibrium. I'm going to again recap. Number one is temperature, how temperature can affect the position of equilibrium. Increase in temperature shifts equilibrium towards endothermic side. And for pressure, change in pressure shifts equilibrium towards, or increase in pressure shifts equilibrium towards less number of mole, and change in concentration shifts equilibrium towards less concentration. Now, if number of moles on both sides they are same, for example, here you have a reaction that is hydrogen and I2, or suppose this is chlorine Cl2, both are reacting with each other to form to HCl. So this reaction was taking place post 10 atmospheric pressure. If I change the pressure, suppose I'm going to make it 20 atm, what will happen with the position of equilibrium? On the product side, there are 2 moles, and on the reactant side, there is 1 and 1. On both sides, number of moles they are 2 and 2. Both on both sides, number of moles they are same. So by change in pressure, equilibrium will not be changed, equilibrium will remain same, and neither equilibrium will shift to right side or left side. So these are three factors which affect the position of equilibrium.